use this time, the next half hour, for questions, general thoughts, etc. And then, yeah, we'll try and make sure that we do not spare any detail that is necessary for the full amount of understanding on Monday. So does anybody have any specific questions or thoughts they want to kick it off with?
Yeah, I'll start real quick. So with our project this week, we had to go up to, for our team, we had to go up to the classifiers. And I did a lot of reading, and I was kind of curious. I read that it's best practice to, when you, after you upload your data, to make sure that so I used Seaborn to pull up to make sure to basically have a little chart and make sure that my data was balanced. And I read that that's a best practice, but then I read also mixed reviews on that. So do you think it's best practice to like have a chart there kind of showing that for folks when they're looking at your project? Are charts also good, or should we just leave it to straight up code and no explanations?
Yeah, that's a great point. And you're referring to best practice in terms of just this general idea, right, of communicating class imbalance rather than using Seaborn specifically, right? Just so I know.
Oh, yes, definitely.
Yeah. So this is a great point. I think that oftentimes when I'm giving talks to clients, when I'm consulting, one of the biggest misconceptions that they have is performance of a classifier with no context as to the class distribution. So I think one of the biggest reasons why you want to visualize ahead of time is to allow for people to understand about arbitrary classifiers. So that is just predicting for every single instance whatever the most common class is, right? So this is what AUC and all of its derived metrics are trying to account for, is the fact that your model performance needs to take into account the actual distribution of classes, because if it's severely imbalanced, then it can simply predict whatever the most common is. I think also, especially for NLP, it can be important to give people context as to the amount of training examples you saw per class, because it gives people confidence that you've adequately learned a language space based on its complexity. So for example, in the schizophrenia form, if your downstream task was something more specific than just labeling it as the schizophrenia form, and for example, if you were trying to find instances of medications inside the topic posts, then you're going to want to have more examples there. And that's because it's harder to find specific instances of those types of textual phrases when you're talking about medications. So it's very problem dependent or specific as to how big of a factor class imbalance can be. But I think in general, it's always a good idea to include, because if you just give people metrics without any context of the class distribution, they can be very misleading. And I think when you're consulting in general business contexts, this is especially important because they're not data scientists or statisticians. They've never done computational work ever. They're just taking your final metric and assuming that some sort of qualifier as to how good your model was. And again, you need context to describe those things. So that's a great point, and thank you for bringing that up. I would definitely include that.
Cool, thank you.
Mm-hmm.
Hey, Colin.
Hey.
So yesterday I started working with the BERT model. I was able to truncate the each sentence into 50 tokens and then try cosine similarity over that. And I've got good recommendations. Like they were not perfect, but yeah, they were making a little bit sense to me. Then I've tried increasing the number of tokens to the maximum, which is like 512, and then I've seen that the model is working slightly better than the previous one when I took just 50 tokens. But I just want to know if there is any way I can quantitatively measure its performance by any chance.
In that context of topic recommendation, it's very hard. I mean, obviously the metric is distance, right? You're trying to decide which of the token lengths or sequence lengths that you're putting into BERT gives you the shortest distance from the nearest posts, right? So you can just rank all of the distances. So you could say, what are the top 5 posts using this technique or this sequence length? And then you can have some summary measure of what are the distances with each. But they don't really mean that much. It's more of a relative assessment, right? So you're not really caring about the absolute score. You're caring about, does a human on the other end think this is a quality suggestion or suggested topic post? So there's not really any way to do this other than I've seen people in companies try and do something where they ask humans at the end of the process, what is the quality of the recommendation on some scale? So they will go on, like Mechanical Turk or something like that, and they'll ask, out of 10, from 0 to 10, how good is this suggested topic? And the way that the person is supposed to rank that is by saying, how related are these 2 topics? And then you can gather a ton of data as to which is producing better results when you have a scale like that. But from my perspective, that doesn't really mean that much. Only if you really needed to quantify something and present to a team that had no other understanding of this model architecture would you need to do something like that. And it's fairly expensive also to add that in as a layer. So really, the main answer is it's very subjective, right? I mean, again, 2 individuals can rank a pair of suggested topics as very similar or not similar at all, based on their own experiences, words that they've seen or used themselves, and then their subjective assessment as to the idea being conveyed. So other than just getting the distances and saying, on average, we are having shorter distances using this sequence embedding technique, there's not much you can do.
I think that answers the question a lot. Thanks a lot. I just have one more quick question.
Yeah.
I think I've missed this point in your lecture, but I'm a little bit confused on this part. How is a bidirectional LSTM is different from an attention-based model? Like, is there any similarity at all?
So this is a fantastic point. So had I been able to do the webinar, I think it would have answered that question, because I talk about this exact point, which is what is the main benefit you get from using attention as a device. The short answer is that if you have a bidirectional LSTM, the way that you exploit both directions is still completely independent. What I mean by that is it reads left to right in one sequence, right? And then it would read right to left over the same sequence. But you'll notice that in both of those operations, it does not exploit context on both sides of the target, right? It's going from one direction and it has a result. And it's going in the opposite direction and then it has a result. And then those 2 results are added together in some way or leveraged as an interaction. And so when it's doing either of those passes, information on the other side is not included. So when it reads left to right, it doesn't have any surrounding context on the right side of the target word. When it reads right to left, it doesn't have any surrounding context on the left side of the target word. And what attention does is it will actually look at all of the pairwise interactions. So regardless of the target word, you're going to be able to leverage context on both sides from the very bottom to the top of the neural network. So LSTMs, again, are using both directions, but they're still independent from each other. It's called shallow bidirectionality. So what transformers do, and it specifically BERT does, the reason why BERT was innovative is that it was the first truly deep bidirectional attention-based neural net. And so that's a really big difference, and it's leveraging contextual information in a more complicated fashion than using a bidirectional LSTM. So hopefully that gives you a little bit of an idea as to why that's the case. But then also, please feel free to bring this up during the webinar, where I'm going to show this, I think, graphically, and it'll make a little bit more sense after that.
Thanks a lot, Colin.
Yeah, no problem. Great question.
So, Colin, this question was actually posed by a lead earlier this morning, and we were unsure about any answer to it. But what exactly are we classifying? Like, what are we using the classification for? Is it for like recommending like a forum category to post in, or what kind? Like, what is the end goal?
Oh, so I'll split it into 2 things. So the immediate thing that you are classifying is the source forum for a given piece of text, and you could think of using this in an automated fashion. So the actual applied use of this is if you wanted to recommend or place automatically a given sequence into a forum. So say you had a very general forum, right, a meta forum that people were posting whatever they wanted into it. And you wanted to be able to say, I want to group this into meaningful categories where the communities feel like there is a common thread or link inside of them. So you want to assess and assign a given post into one of those categories automatically without human intervention or labeling. So in this particular problem, the thing you're classifying, again, is the source forum out of a group of different forums. And then you can use that information to try and get an understanding of the latent features or attributes in the linguistic space that define a given forum. So hopefully that answers that question as to the actual thing that you're trying to classify.
Yeah, that makes sense, definitely. And then if we have enough time, we could actually deploy that using Docker, right? And do that
Yeah,
entire
exactly.
business side. Yeah.
Exactly. So that's something that's coming to, based on the differential progress in teams. One of the things that's the most important in the modern era is after you build a model and it works, you need to actually productionize it or deploy it somewhere. So a model is only useful if you can actually call it. And typically now the way that people package models is by using what's called a Docker container. So some of you may be really familiar with Docker containers or Kubernetes. Some of you have never heard of that before. Docker containers are kind of like virtual machines. And if people are interested moving forward and they've already completed the rest of the tasks, I might do a whole webinar on Docker containers and their utility. But basically, you can wrap your model in PyTorch or TensorFlow or whatever you end up using into a Docker container that is guaranteed to run identically, regardless of the host operating system. So that's why it's kind of like a virtual machine. But the main difference is that Docker containers actually share a kernel, if you know what a kernel is on the host machine. So what we're going to end up doing is after we build a model and verify that it's working, we're going to wrap it into something that can be deployed or called in real time. And we're going to use AWS to host this. So for example, you could have an app on your smartphone where you could type in a textual sequence and press enter, and it would send that data to the Docker container that exists at AWS. And then it could crunch that and return back the predicted forum that that piece of text came from. And then you can start to evaluate it in that fashion. So that's kind of the more advanced full end-to-end goal here is building a useful model and understanding what's going on underneath. But then there's still a very critical portion that's left out of that, which is what do you do with that model? How do you make it useful to people beyond just yourself on your computer? So we're going to be seeing some of that later as well.
Yep, and the really cool thing about these projects is that if we have time, and definitely we'll be doing it in the second session, we can actually integrate all these different aspects of like Stemway together to make like one really cool product. So like, for example, we could have full stack working on like the integration with our machine learning model, like into the Stemway website, and then we can have UX design the landing page that we use for it. So it's just like a kind of cool, integration of all these different aspects of Stemway all together into this one really cool product.
Yeah, that's a great point. And to just build off that, this is the way that a lot of teams work now. So if you work in a pharmaceutical company, you're working with a bunch of clinicians and IT people and data engineers and data scientists. And everybody is leveraging sort of these very common skills and common languages, but everybody has their own area of expertise in order to take something from idea to actually learn something to deploying it in production. And so it's a very useful sort of workflow to get around, which is working with different teams, like Shreyas just said, and then handing off your products or models that you build and making them useful to everybody. So hopefully by the next session, that's kind of up and rolling. That'd be really cool.
Yep. And the next thing is that I'm not sure if you guys know this already, but they really announced that we're going to have an extra optional 3 weeks. So in addition to the 5 weeks that we have for this internship, if any of you want to, you can stay on for the extra 3 weeks and you can continue working on our projects. So it's optional whether you're a lead, participant, observer, it doesn't matter. It's completely optional, but I recommend that you guys do it just to get the extra experience. So. And Colin, I don't know if Dablina has told you about it. Has she already?
No, I haven't got a chance to speak with her yet. Our calendars haven't synced up. So I am probably going to call her tonight or sometime this weekend, and we'll talk about the logistics.
All right, perfect. And of course, that's extra time if you guys want to, if there's a lot of enthusiasm about the whole Docker part of it, at the very least, we can teach you guys if you want. So.
Yeah, this actually, it's not so much to do with the project per se, but I was wondering, I came into machine learning. I'm in finishing up my computer science degree, and I actually do love it. So what are the next steps? Colin, what would you recommend us to do after this internship? It is I have to be a little blunt or a little frank. It is a little disheartening because you see a lot of the stuff for machine learning, a lot of the jobs for that. They require like a master's degree or a PhD.
Yep. Yes.
So
Yep.
is that like kind of the mandatory next steps in everything, or is this just something that like, or do you have any places that you would recommend us to go to continue our learning?
Yeah, so this is a really great question because it's hyper relevant to my own experience. So I don't have a PhD either. And so I've consistently been given this feedback that in order to walk up the promotion chain, you need to have a PhD. In order to be titled certain things, you need to have a PhD. And so it definitely is, like you say, a disheartening reality that if you want to work as a principal research scientist or in a really large company as a sort of core data scientist, typically you will need to have a PhD. They'll expect a computer science degree from a top school, but that's definitely not necessarily going to sort of smother out the chances of working as a data scientist somewhere. So some of the other paths you can take are doing a stint in academia. So that is what I chose to do, and work on this drug repurposing project doing machine learning in academia. So that's a little bit different because in most academic groups, unless it's a computer science team, they're not going to have data scientists working there. So you might be the only one. So that's both good and bad, right? Because you can differentiate yourself, you can build skills, but also you're not going to be working on a huge team. So one of the big benefits of going to a place like Amazon or Google is that you'll be working with a bunch of like-minded people with, similar goals, and they'll have similar backgrounds, et cetera. So I think one of the best ways to differentiate yourself is to start working on a portfolio. So we were talking about how you can add the STEM Away project onto your GitHub page and have that GitHub page act as your portfolio. But again, really what people want to see if they're going to choose to hire a non-PhD or non-master's data scientist is a fully fledged end-to-end project. And so a project is very different than code snippet or blog, right? Blogs are very useful too. But really, when there's project, there needs to be actual value in it. So you need to have solved the problem for some company, some group that relies on data science and software engineering. And so I would definitely recommend using this experience to start thinking about what goes into a full project. And that's why if this is interesting to you and you plan on getting the title of data scientist or machine learning engineer without that PhD, you should definitely stick around for the Docker piece, because this is becoming a reality where if you can't deploy models, people will not hire you outright. So that's if you're going to work at a general company as a data scientist. But again, in these academic positions, there's not as much of an expectation as to the technology stack you would have seen. So sometimes academia can be that bridge to show that you worked on a complex problem methodologically, and you worked on very cutting edge data sources, but perhaps you didn't have a full software engineering team building sort of like a UI and a big product and an application. So there's a lot of different directions you can go, but all of them will consistently suggest that you have worked solely yourself on a project that you can demonstrate with a repo, and that project has solved some sort of maybe business application or academic question, or you've done some modeling on an open source data set even. So there's essentially no barriers to entry to do these projects, right? Because you can leverage free data. Most of the technology you need is going to be open source. GitHub is free now. So there's no barrier to entry in terms of the software that you need to be using, but there's a huge barrier to entry when you're going to apply, because you're going to need to have shown that you can do the job before you get the job. So it can be really difficult when you're starting out if you are not on a straight shot to get a PhD from, Stanford in computer science, because it really can feel like when you're applying to machine learning engineering jobs or data science jobs that what they're looking for is a PhD in computer science. But there are definitely ways where, like I was saying, you can bridge that gap. So I don't know exactly what your intended next steps are, but I would definitely recommend starting to think about, for example, can you solve the problem of a local business using machine learning, and can you demo that in an application somehow? So definitely start thinking about those questions.
Cool, thank you. Yeah, at the I didn't really know much about machine learning before starting this internship. I mainly before this I was mainly kind of a front end person, and I decided to go back to school, finish my degree, and so I've been working using Java, and I love SQL. I've learned that like the thing that I loved the most about JavaScript was iterating through large amounts of data. I love the structure of Java, but then I learned SQL, and I'm like, oh, data. And then I'm noticing a trend here where like I actually really love this project, and like, oh wow, I really love data. I love large amounts of data. So I'm noticing a trend here. I do have one other quick question. Speaking of Java, I did hear that I did read that Java used to be a machine learning programming language, but then they made the jump to Python. Is Java no longer used for machine learning at all, or?
It's tough to accurately answer that. I would say for sure, if you were going to apply for something that's titled data scientist or machine learning engineer, the expectation is Python and R. And maybe for optimization's sake, some C++ if it's a very specialized area. So again, I think I gave this example, but finance definitely expects to see C++ if you're going to work at, quantitative trading, et cetera. But Java has been useful for things like MapReduce, where some of the original implementations were written in Java. And so it definitely has like a storied history in certain pieces of technology, but it's old and antiquated, and most of the things that you could have done with Java can be better performed in a language like Python if you don't care about efficiency, or Scala if you do care about efficiency. But Scala is definitely the more modern implementation of some of those libraries, especially in Spark. So I think that, yeah, there's not too much of a need to learn Java. It's great if you have it. It's very cool. And typically in interview situations, it's not going to matter necessarily. You just have to show that you do know Python and R. And then if you choose to solve like an algorithmic question in Java, it usually doesn't matter. But that's going to vary widely based on the company you're interviewing at and the title itself. But I do also want to mention, when you say SQL you're interested in, SQL is definitely one that people will ask experience in too. No matter what you end up doing, if you're a data analyst, a data scientist, a machine learning engineer, typically you're going to need to have some sort of SQL skill. And SQL is pretty easy to pick up if you're already proficient in another language, but it can really be sort of a problem solver in a way that other languages can't when it comes to managing data. And I think one of the other, I guess, disheartening reality is oftentimes people think they're about to start a machine learning job or a data science job, and they end up doing something more similar to database administration and, I guess, semi-complicated SQL queries. So that can be good too if you're into that kind of thing, but that's something to look out for as well, that SQL is definitely a core skill that people ask for. And oftentimes it can be a big majority of what you do as a data analyst or scientist. So it's cool that you already have experience with that.
Cool, thank you. Yeah, unfortunately though, for like a computer science degree, they really push Java and C++.
Yeah, they do. Yeah, that's definitely my experience. So I didn't get, my degree wasn't in computer science, it was in statistics. So R was kind of the lingua franca. But all of my friends, and I took many computer science classes, they're all taught by default, typically in Java, right? Or then you graduate to C++, and you spend more time on those types of languages than you do with languages that are geared towards manipulating data. So oftentimes having advanced Java or C++ can act as a signal that you can learn Python, because typically people will assume that you can pick up some of those more specific libraries or languages on the fly if you are very advanced with a programming language like C++. But oftentimes when people are evaluating your portfolio, they're going to be looking for how good you are with Python and R and what you've built using frameworks like PyTorch, for example. So it's definitely not a detriment. It can only help, but it's definitely not the focus either for things like data science or machine learning positions.
All right, cool. Thank you.
Mm-hmm. Yeah, I would definitely say on this general theme that machine learning and data science principles are the types of things that are very easy to get started doing, and they're very cheap to list on a resume. So oftentimes recruiters have headaches because anybody can put advanced Python, machine learning experience, neural networks, deep learning, etc. They're very cheap and very common to see. And so when we've been interviewing in our group, we've had to do this too, where it's just very difficult to evaluate whether or not somebody's good at something, which is why the trend is definitely looking at somebody's GitHub page and seeing the project source code of something that they built, and whether or not it actually demonstrates an understanding of some of these machine learning concepts. Because you'll notice with something like simple transformers, the API is so easy to call that it can be very easy to misconstrue whether or not somebody actually knows what's going on underneath the hood. And so definitely separating yourself from the pack and demonstrating that you actually do have that theoretical knowledge is going to be a necessity too, if you want to be something like a data scientist or machine learning engineer. So that's just something to keep in mind.
Cool, thank you.
Mm-hmm.
I just want to say, like, sorry to talk so much, but I just want to say that it's interesting that they try to shove Python at people as a new person language. I do not think that, like, I kind of came into the internship obviously with like more Java, more Java, more SQL, more JavaScript experience. And so the way, I mean, I came in with knowing some Python, like basic baby Python. So like the way I've been figuring out and solving problems have been like, oh, how would I solve this problem in Java? How would I solve this problem in SQL? How would I access this? And so, and then translating that over to Python. So I think that like Python, I can't imagine anybody, not having the core background of like, I don't know, Java, C++, JavaScript, and coming into this, and I don't know about, maybe it's just me, but I would be entirely overwhelmed. I have so much respect for anybody who's coming into this and just learning this like on the fly. But yes, definitely Python has so many levels, and I do think that you need to understand other languages too. That was just a little point that I wanted to add on there.
Yeah, that's a great point, because I do think Python can be deceptively simple, right? Where at the very highest level of calling pre-existing libraries, it can read again like pseudocode. But like you're suggesting, when you actually need to solve a problem or implement an algorithm from scratch, you can quickly find yourself overwhelmed because you are not familiar with design patterns. So I think that's the biggest difference with computer science degrees, right? And if you were taught via Java and C++, is you're much more focused on design patterns for software engineering than you would be if you were using Python the entire time. So I definitely agree that sometimes, you know, Python can be misleading. It definitely is the language of choice for all of the deep learning stuff. But I think that if you can understand what's going on underneath the hood, you can demonstrate that you understand deep learning at a much more detailed level. So it's definitely good if you can show that you're proficient in another language outside of R and Python, because it typically suggests that you're more familiar with design patterns and more adept at software engineering as a general practice than if you only had those two languages. And also it's something that I think is pretty common is in interview situations, people will sometimes ask for Java if they are focused on productionizing or making dashboards. So that's another flavor of data scientist or machine learning engineer you will encounter in terms of Java applications in the wild, is some combined Python and Java experience, and then building simpler models and then spending more of your time and making them into dashboards and productionizing them. So people want to know that you can pick up new frameworks or new languages relatively quickly, because this landscape is changing, right? I mean, as we just said, Java used to be something that was much more integral to the big data toolkit. And I think that's less relevant now. So every single year, it seems like there's a new framework, there's a new deep learning library, there's a new best language for a certain type of task. And just getting your head wrapped around pivoting to something completely different can be very, very healthy early on, because then you won't find yourself as overwhelmed when you're tasked with learning a completely new framework or language on the job. So I think it's great that you already have experience with all of these different languages, each of which was designed to do very different things. So that's fantastic.
Oh, thank you.
Definitely. Anybody else have any other general questions, career related or project related? Nope. Okay, cool. So then, like Shreyas and I said, next Monday at 4 p.m. Pacific time, we will resume with the webinar focused on the actual BERT internals, and then hopefully that clarifies any remaining questions you might have, because I think most teams now, oh, we have a question here. Do you think writing about your projects is highly, let me just see, do you think writing about your projects is highly important for hiring managers? So yes, I think that it is critically important. Not only do you need to be able to do the project, you need to be able to communicate it well. So that's both in the context of your job interview because you're trying to sell yourself, or your phone interview because you're trying to sell yourself, but also because it's becoming increasingly necessary that data scientists or machine learning engineers face all other members of a tech stack, or even people that aren't technologically adept whatsoever. So like Shreyas was saying, one of the main goals or ambitions that we have with this overall project is how do you interface different teams that are working in different domains together? And so if you can't adequately communicate the internals of your project in a way that's targeted to the audience, then they're going to pass on you, even if your code looks really good, unless it's a job that only really cares about production quality code. So again, this is going to be dependent on the place that you're interviewing for. But I think the vast majority of jobs are equally as focused on your communication ability as a data scientist as they are on your programming ability. So being able to summarize a project in a few lines can be really tricky. And then sometimes it can be even harder to summarize it in a few paragraphs, because how do you hit the proper beats of what you did and why you did it and how you interface with that project? So technical documentation is kind of like a dying art in a sense. Sometimes people are taught from the very beginning to comment their code very well and annotate their projects cleanly, and their readmes are initialized very well. But I think that that's not going to be the majority of the time. So another way you can separate yourself is how good can you communicate these ideas and your work itself to somebody that may not be a software engineer. So the typical hiring manager, or the first people that are going to be doing the screens, are going to know the general things to be asking for. They're going to probe you for different languages. They're going to be behavioral questions, et cetera. But then when it comes to communicating specific projects, you need to be able to know immediately the level of detail to dive into when you discuss these things. So I do think writing and speaking about your projects is equally as important as doing the projects themselves. So hopefully you can get some practice by the end of this project with trying to figure out, for different audiences, how would you describe what you did? How much detail to go into, and how to frame. Because I think that when you're trying to do job interviews, you need to position yourself as somebody that can accomplish that specific job, and tying your project into a specific job is going to be really valuable in that context. So hopefully that answers that question. So writing Medium articles, for example, is recommended. Yes. So I think it's a great idea to either have your own blog or contribute to Medium, or have a blog that points to Medium articles. They don't need to be perfect, and people aren't going to expect them to get a ton of claps or favorites or likes or whatever platform you're using. But just as an educational experience for yourself, writing Medium articles is going to be really important. And then getting that initial wave of criticism and feedback and understanding why what you're trying to communicate can be difficult is going to be really important. So I have many friends that write Medium articles, and sometimes they put them on their resume themselves because they can be an extremely powerful indicator as to how you're going to be able to plug into a team that might be full of people that aren't as skilled as you in that particular job. So it's definitely recommended writing articles, blog posts, doing interactive visualizations, and just to get a feel for whether or not you're conveying these ideas properly to a variety of audiences. No problem. So we have another question. What does a typical data science interview look like? So again, this one's really difficult to answer unless you have a specific company and title in mind. So again, there are interviews for data analysts, data scientists, and machine learning engineers as a broad trio. These can change based on where you're applying and the amount of experience you have. But I would say for something titled data scientist, typically there will be phone screens that are really behavioral in nature, and they'll talk about past experience, they'll talk about references, etc. And then if it's a really large tech company like Google or Amazon, the interviews they kind of follow a set structure. You can look this up online, and you can go to HackerRank, for example, and look at types of questions that are asked by certain companies. So different companies tend to favor different types of data science interview questions because their products are achieving different goals. And so you might have certain questions that are focused on optimization algorithms, for example. So if you were in an Uber data science interview, you might get asked things that almost resemble econometrics questions that are supply and demand pricing models. And they will be a mix of domain specific to that company at the sort of towards the final end, and then also very general that are talking about basic algorithms and basic statistical questions. So for data science interviews for larger companies, typically they can be one of two flavors. One is much more of a software engineer that does data related work. And then one is more of a statistician that is trying to integrate what they do with the rest of the IT infrastructure. So data science obviously sits somewhere uncomfortably in the middle. And it really depends on the language of the job description. But if it's the software engineering flavor of data science interview, it's going to be focused a lot on things like algorithms and writing efficient implementations and maybe talking about time complexity, which is still important if you were in the latter group that's like more of a statistician, but it's not going to be the focus. So in my experience doing data science interviews, I got asked more questions about that latter group, which were talking about, for example, visualizing bias variance trade-off, solving least squares using matrix algebra is a pretty common one. So again, this can vary over time. It can vary based on the company and the problem that you're trying to solve. But what they'll also do, if it's a good, reputable company, is trying to ask you some questions that you should reasonably be able to answer based on your background. So based on your project, based on the languages that you list, based on the types of papers you were listed on if you were in academia, they might ask a question theoretically based on that work and then ask for a rudimentary implementation of that. So, if I talk about regularization and I'm talking about GlimNet and ElasticNet penalties in my phone interviews, and I say that I use that in a project and I say that I published a paper with that, then a very good interviewer might ask me something very specific about that model because it's something I should be able to answer because I've used it before. So they're a little bit dependent on your experience towards the final layers of interviews. But as an overview, they can come in those two flavors, and it really depends on the job title and company that you're going for. So there's almost universally a behavioral screen. It can be 1 or 2 or 3. Google can sometimes be infamous for doing a lot of screening interviews, both on the phone and on site. So I had a friend who had to do 6 or 7 different interviews, and that seems to be pretty common for Google software engineers or data scientists. But again, yeah, you can get questions from the entire spectrum. Yeah, exactly. It's a whole day interview. Yeah. So it can vary vastly based on the company's practices and hiring. But I would say that you have to ask yourself what you're interested in contributing to a team. So if you are framing your projects on more of the software engineering aspect, you consider yourself a very advanced coder. You're very good with full stack. You want to frame yourself as, like, again, a software engineer that does data. Then you should definitely be very aware of all of the algorithms and time complexities of those algorithms. And I think that going on something like HackerRank is very good practice in general, regardless of whether or not you're going to get interview questions like that. It'll really help you think about computer science principles at a high level and get familiar with writing code under pressure. And another big component to all of these interviews is that inevitably you will get asked to do whiteboard implementations. So don't get too fixated on your IDE of choice and practice writing code on paper. It sounds like something that might be really simple, but it can end up being absurdly difficult, even if you're an amazing programmer, if you've never done it before. So just getting used to, like, for example, solving the least squares, both in pseudocode and the actual matrix algebra solution on a whiteboard is something that you may have breezed through when you were in college, but it can be very rusty and you can lose your footing very quickly when a group of strangers is staring at you while you're trying to do it. So I would recommend throwing yourself into these simulated scenarios, right? Where you just ask yourself, could I do this on my own right now, outside the context of an interview? And just practice being in those situations. Because if you haven't done the gauntlet of tech interviews, it can be really overwhelming in the first couple because you have never been in a situation like that before. But if you're already very familiar with the interviewing process and are good with doing pseudocode on whiteboards and writing performant code under pressure, then I would study the fundamentals of data science. So things like bias variance trade-off, talking about how neural networks are composed, different architectures, talking about why regularization is so important, just principles like that. And just being really familiar with the things that you talk about in your resume. Because I've had some really specific questions thrown at me that are based on an algorithm that I hadn't even really thought about in a couple of years. So you never really know. But it's hard to describe. That's a broad overview of what you can expect for those types of jobs. So we have a question. When targeting a deep learning engineer job, do you think having a PhD is a huge plus, or an engineering degree with side interested projects is enough? Yes. So if your title, now this is changing rapidly, I think, but if your title is deep learning engineer, typically you're going to have a PhD. So the more common setup is machine learning engineer, and they will be doing deep learning for sure. But I think that it's more permissible for something titled machine learning engineer to not have a PhD. But again, this is rapidly evolving. So I think that people that are tasked with designing architectures and sort of guiding the methods development as to what kinds of data do we collect, what do we do with that data, how do we actually form new representations, how do we condense this existing model architecture into something new, they're almost always going to have a PhD. And that doesn't mean you can't be a machine learning engineer without a PhD. It just means that if you want a job at Google doing it, or you want a job at a pharmaceutical company or at an academic institution, you're definitely going to need that PhD. So I think that if you have an engineering degree with side and interested projects, you can easily get titled data scientist right now or a machine learning engineer easily. And if you're really good with many years of experience, 5 to 7 years of experience, you can have a title change. But for something that's called principal researcher or principal engineer, typically you're going to need to have a PhD for something like deep learning. It's more reliant on mathematics and methodology than pure software engineering, as a really broad generalization. So if getting a PhD is something you're interested in, it can open many doors that you otherwise would never be able to even see if you didn't have that PhD. Yeah. So if you have a type of job in mind, I'm happy to talk with you either one-on-one, or if you want to bring it up in the context of another Q&A and just ask for, would somebody reasonably require a PhD for this? I can tell you my assessment from my personal bias. So again, being in academia and working closely with pharmaceutical companies and biotech companies, I know what the norm is in that space. But for something like, a startup, I'm less sure. I have friends that do not have PhDs that have ascended to really high levels of machine learning or data engineering jobs. But that's a dichotomy that's also important. Data engineers typically will not have PhDs, whereas machine learning engineers more often have PhDs, in my experience. So if you find yourself really adept at the infrastructure side and doing really advanced things with big data interests you and warehousing interests you, then definitely consider data engineering titles as opposed to pure machine learning engineering titles, because the latter will likely need some form of higher education. Would you be able to do another webinar on documentation specifically for projects? Yes, I think that's a great idea. So I would love to be able to do that once we get to the point where results are being written up and notebooks are assembled. So I can talk through some good and bad examples of documentation, but I think the more important piece of that is conceptually, how do you want to document things for particular audiences? And that's a type of soft skill that doesn't really get taught at all. And oftentimes you don't necessarily need to do it if you're content with just taking, the first job and you know exactly what you want to do. But if you really want to take into account all of the possibilities, it can be really important. So I think we should definitely do something like that, where we're talking about communication and documentation, both written and spoken, in the context of machine learning. Because I think that that's another way, again, that you can really separate yourself from somebody that can use all the libraries, can write performant code, has a couple internships that are really great at tech companies. But if they're really poor communicators, oftentimes you can make the case that you're going to be a better fit for a certain type of job. So let's definitely do something like that towards the latter half. Yeah.
Yeah, and just to add on to that, STEMway is kind of like the place where we really want to like foster that kind of skill and that ability. So if you guys have one thing that you want to if there's like one goal that you guys should pursue where you're here, it's to improve your soft skills, because those are they usually end up becoming like the most important factor. So.
Yeah, I would definitely echo that sentiment. So if, for example, you end up getting a PhD at Stanford in computer science, this stuff doesn't necessarily apply to you because you're going to have a very narrow focus. You're going to get a job immediately. You're going to be paid very well. It's going to be great. But the reality is it's incredibly difficult and time consuming. And some people that could have done it don't even choose to do that. So I think what Shreyas is suggesting, which I completely agree with, is if for the vast majority of us that have these skills but don't exactly know where they fit in the context of a company or a product or a research group, I definitely agree that the soft skills are equally as important, if not more important, in differentiating yourself. So I think that this is kind of like a playground where there's no penalty for miscommunicating something or asking a question or trying to figure out something that you maybe should have already known to do this in production. So we're trying to foster that, like you're saying, and develop these things, and then talk amongst yourselves and just try and figure out, is it easy for each other to understand the documentation that you write? And then hopefully after this webinar and with some actual experience, you guys begin to get a feel for why you would want to frame something a certain way for a certain interview situation. And that's really sort of the practical end goal here is, how do you get hired in the place you want to get hired for the job you want to do? And just filling in some of those gaps that can make that a difficult task. Cool. So any other general questions or things that maybe you want to see taken on either informally in a Q&A further down the line or in a specific webinar? Or is there something you've wondered, technology that maybe you want to see? Does it relate to this? Can you use it? You've seen it in some of your own job applications or something along those lines?